This is Lesson 65, Geometric Sequences, on pages 150 and 151. A geometric sequence, if you remember an arithmetic sequence, is when you're given a set of numbers and you're adding. You can see that common difference that you're adding. Well, a geometric sequence is going to be where you're going to be multiplying by the same number. We'll take a pretty easy one. Let's take 5, 10, 20, 40, ... Okay, now look at that. You know, if you only had the first two terms, you could say, well, I'm adding 5, and the next term should be 15. So you got to have at least 3 terms to be able to determine if it's geometric or arithmetic or neither one of those. So in this case, you say, well, from 5 to 10, well, I can add 5, but that's not the pattern. And notice that I'm multiplying by 2. So in this case, you are going to multiply by a common ratio, and that letter is R, to get the next term. So in this case, R is equal to 2. We're multiplying by 2. Now, if you want to find, remember there's explicit and there's recursive formulas. Well, recursive is just going to be taking this term, multiply by 2, multiply by 2, multiply by 2. You're just going to take the term in front of it. But the explicit formula is going to be a sub n is equal to a sub 1 times r to the n minus 1. So you have to be careful with your exponents when you're doing the calculator. But we're just sticking with integers, so that makes it pretty easy too. So if I want to say in this particular problem, we'll call this problem number 1, that we can see all of it. Let's find, let's say we want to find the 20th term. Okay, so a sub 20, n is just like it was before. That's the number of term, except the first one. A sub 1 is your first term. And there's your n again, and then your r is your common ratio, what you're multiplying by. So a sub 20 is equal to a sub 1, first term was 5, times r, which we said we were multiplying by 2, and it will be raised to the 20 minus 1, or 19. Now, I may have picked too big a number. Let's see if we can do that one on our calculator. So I've got 5 times 2 raised to the 19 equals. Now, sometimes when you get really big, it's, and we need to put commas in that, that'll help too. I'm going to write it 2, I think it's 2 million. So 2621440, and I'll have 2,621,440 is the 20th term, because you just as you keep multiplying by 2 as you go up. Next term would have been 80, and so on as we went through that. We try to stay away from like the 100th term, because your calculator many times will kick into scientific notation and you just have to use that rounded value. So we try to stay away from that. Okay, number 2, we're going to use the sequence -3, 9, positive 9, negative 27, positive 81, ... Now, something that you have to watch here is when you're thinking about signs and you're multiplying by the same number. And as I said, you can we know that with arithmetic you can subtract to find out what your r is. So just like up here, we could have said 10 divided by 5, or 20 divided by 10, or 40 divided by 2. And all of those gave us that the r was equal to 2. Well, here, if we take the 9 and divide it by the term in front of it, we're going to get -3. If we take -27 and divide by the 9, I get -3. So in this case, my r is -3. And you can see that. Times -3 would give you positive 9, times -3 would give you negative, and you see how your signs are alternating. The explicit formula Oh, and I didn't stop and do just the formula. We just found the 20th term up here. But let's find the specific explicit formula for it. And that's, remember, when you don't put an n into the problem. You're saying for any generic term. And it's pretty easy on this. There's not any extra arithmetic to do because I've got a sub n is equal to a sub 1 times r raised to the n minus 1. So a sub n, because I'm talking about any generic term, is equal to a sub 1, which is negative 3, times r raised to the n minus 1. Oop, and my r was negative 3. Now, you do need to put that in parentheses here, because remember, raising a negative number to a power can alternate signs, so you have to be very careful. And so then it would be raised to the n minus 1. Now, there is a way to simplify that. We're going to leave it, because most of the time they're just going to leave it at the high school level, going to leave it in that format. So that's pretty easy. So let's find the 11th term. Actually, we need to find the 12th term. Okay, so a sub 12, and there's my formula right there. I'm just going to plug in, is equal to negative 3 times negative 3. So in this case, you see that the first term and the r were the same thing, raised to the 12 minus 1, which is 11th. So as I'm going to do that, and if you think about it, you're really just raising negative 3 to the 12th power, because you've got 1 here and then on number 11. That happened in that case because it was the same r and first term. But I'm going to do it just like it's set up. So I'm going to say negative 3 times, and then I'm going to put in parentheses my negative 3 raised to the 11th. And notice that I did get a positive number because you were multiplying negative 3s. You were multiplying actually 12 negatives. And so you end up with 531,441. Okay, I'm on page 151 now. And just tweaking it just a little bit, we're going to actually start with the explicit formula. And they just ask for a specific term. So I'm going to say a sub n is equal to, let's use negative 4 times 2 raised to the n minus 1. So they've given us the generic formula, and we want to find the, let's see, they asked for the 12th term. We did that number 2, so let's do a different one. Let's do a sub 15. Okay, so we're going to plug in. So I've got negative 4 times 2 raised to the 15 minus 1, which is 14. Now, notice in this case, and that was just sometimes it happens that your r and your first term were the same, but see, my first term here is negative 4. So when I go to, and you can see that by putting 1 in, you can find your first term. If you put 1 in, you get 2 to the 0, which is 1 times negative 4 is negative 4. And in our formula a while ago, over here, see, in our formula, a sub 1 is your first term. So here I need to know the 15th term, so I've got negative 4 times 2 raised to. Notice I didn't have to put it in parentheses because it was a positive number. And I got negative 65,536. Okay, let's try one more of those. Let's do a sub n is equal to 5 times, let's do negative 4 to the n minus 1. And they will put that negative in parentheses in when they're giving them to you in the problems. And let's find the, I'm going to get into some big numbers pretty quickly. So let's do the 5th term. So we've got the first term is 5. We're just plugging n in right here. So I've got negative 4. This won't be too bad. And we'll have 5 to the 4, which will be 5 times, open parentheses, negative 4 raised to the 4th. Now, if you don't put it in parentheses, you can miss a sign. You know, you got a 50-50 chance you're going to get it positive or negative. Here I know it's going to be positive because I'm raising a negative to an even number. So in this case, I got positive 1,280.